going to look at solving linear inequalities in section 2.4. And some of what we do in this section is going to be very similar to when we solve linear equations. Yeah?
I was just going to ask if you had recorded that as well.
Yeah, I think I... Yeah.
I just wanted to make sure you did.
Thank you. One special thing can happen with inequalities, though, and it can happen when you multiply or divide by a negative. So we just have to remember what can happen if you multiply or divide by a negative. We'll go through that. We'll just make sure we remember the names of these symbols going from left to right. Quinn, can you tell me what that first one is?
Greater than?
Nope, that's a less than. So less than. Manny, this one?
Less than.
Less than or equal to. Caleb, how about this one?
Greater than.
That's the greater than. And of course, when you put the line under it, greater than or equal to. Okay, so those are your 4 inequality symbols. And there's a couple examples of inequalities. The one on the left is just a true statement. The one on the right is a conditional inequality. And it could be true if you pick the right value for x. So let's say that I wanted to check if 5 is a solution to that inequality. 3x is greater than 12. The way you check if a number is a solution, you plug it in, and you see if you get a true statement. So if we plug in 5, I just picked 5, I just made it up. 3 times 5, is that greater than 12? Yeah. So that we get 15 is greater than 12. That means 5 is a solution. How about if I plug in 4? 3 times 4. Is 12 greater than 12? No. So 4 is not a solution. What's different about inequalities is there's usually more than one solution. Right? That's pretty normal. Right? And the solution to this problem would be any number that's bigger than 4. How many answers are bigger than 4? An infinite amount. So one special type of inequality that you can have is a conjunction. And that's when you have 2 inequalities connected with the word and. This type of inequality usually ends up meaning between. Like if I said to you, pick a number that's greater than 0 and less than 10. Effectively, what I'm telling you is to pick a number between 0 and 10. Now, when you write 2 inequalities and you connect them with the word and, you can shorten them. And the way you can shorten it looks like that. What you do is put the variable in the middle. You put the smaller number on the left. You put the bigger number on the right. And both inequality symbols point to the smaller number. And if you break that up, you can kind of see each one of these inequalities in the combined one down below. So the one in the red box is right there. X, and then it's pointing at the negative 1. X, it's pointing at the negative 1. So there's that one. That one, so the X, and then it's pointing at the 3. It's pointing at the X. Is right there. X, and then it's pointing at the X. How else could I break these up? There's one other way I could do it with the X in the middle. And I could put the 3 here and the negative 1 here. But what would happen to my inequality signs if I wrote it this way? Yeah?
You would flip around so 3 is greater than X and X is greater than 1.
Yeah, you could also do it that way. And then the X is greater than negative 1. That's the red box. And 3 is less than X, or 3 is greater than X. That's the green one. So when you combine it together, one of them always has to flip around to make this work. That's just how it works. Either way is right. I usually do the way on the left. I don't usually do the one on the right. So smaller number on the left, bigger number on the right, letter in the middle, both point to the smaller number. So the range of numbers here that you are allowed to pick, this is called an interval. Between -1 and +3 is the interval of numbers I'm allowing you to pick from. And we're going to talk about a few different words that can describe intervals. This particular interval is called an open interval. There's open and there's closed. So we're going to talk about what each one of those means. There's also something called bounded and unbounded. This type of interval is called bounded. So we wanted to be really specific about it. This is called a bounded open interval. And I'm going to show you what those words mean right now. So bounded means that in your interval, your endpoints are a number on the left and a number on the right. Two numbers. And if you think, well, what else could you have in an interval besides a number? There is a symbol that we've used in intervals before. That's not a number. So think about that. We're going to talk about that next. But as long as you start at a number and stop at a number, that is called bounded. Now, when you start and stop at a number, we have to be a little more specific and say, well, do you include the number you're starting at, or do you not include it? Like if I say, pick a number between 0 and 10, does that mean you can pick 10, or do you have to be less than 10? Like what does between 0 and 10 mean? And that's what this word helps us to describe. A closed interval is an interval where you can include the low value and the high value. That's why you put a bracket on. So if I said to you to pick a number in that interval, you can pick the 0 and you can pick the 10. You can include both. Now, if you compare that to picking a number in this interval, remember that is not a coordinate, that's an interval. It means you can pick a number between 0 and 10, but you cannot use the 0 and you cannot use the 10. That's what the parenthesis means. So an open interval does not include the endpoints. Now there's two other types, because I said there's 4. What else do you think you could have by closed and open? Yeah?
One, like the highest or lowest side is open, but
Yep.
not the other.
Yeah, so you could have half and half. So the third one is half open on the right. And the fourth one is half open on the left. So if you wanted to think of these as inequalities, okay, I'll draw a couple of them for you. A, B. This would be closed circle on A, open circle on B, shade between. This open one would be something like this. Open circle on A, open circle on B, shade between. And the completely closed one would have 2 filled-in circles. Okay, so bounded means that this is a number and that's a number. What symbol do we see sometimes when we write an interval that is not a number? Yeah? Sometimes we see infinity. And when we have infinity as part of an interval, that means the interval is unbounded. So when we see an infinity symbol, that means the interval is unbounded. It means it goes on forever. never stops. Yep.
So just to confirm, the open intervals is including the highest and lowest value. Right?
Open intervals? No, that's an open circle, not a filled-in circle, so it would not include.
So for half open, the B, so it would include the lowest value for that first one, but not the highest.
Right. Yeah, it would
So the
include the,
highest value but not the lowest value.
yeah, it would include the A, but not the B. So there's a couple different types of unbounded intervals we can have, and just maybe 4 examples right there. The 2 on the left are unbounded on the left side, and the 2 on the right are unbounded on the right. And if you wanted to draw one of these as an inequality, this is not a between. This is an arrow that goes in one direction and never stops. So this one would look like this. This basically means any number greater than or equal to 5. This one would be any number greater than 5. That would be an open circle. And the same on the other 2. Could also be unbounded on each end. Like sometimes when we talk about domain and we say it's all real numbers, we put negative infinity, comma infinity. So that means there's an arrow that goes in each direction. It's like you shave the whole number line. And if you want to see more of those pictures, like for the other 2, they are all on page 100 in your book. All right, so let's try taking an interval and writing it different ways. We can graph it. We can write it in interval notation, which is what you're being given right here. Or you can write this as an inequality. That's what they want this time. All right, so this is like a between. So this is where you're going to put like an X in the middle and numbers on each side. Does anyone think they could tell me how to write this as an inequality? Yeah.
-3 is less than x, but x is less than or equal to 5.
Yeah, perfect. That's how you write that as an inequality. You could switch the -3 and the 5, but then you'd also have to switch the way the inequalities point. That's the way I would do it. Any questions on that? All right. And what kind of interval is this? Bounded or unbounded? Bounded, because it doesn't have infinity in it. Is it open, closed, or half open? Half open. Half open on the left. How about this one? Bounded or unbounded? Unbounded. So when you write this one, you don't need an X in the middle and a number on the left and a number on the right. All you really need to do is you're going to write something like X. You're going to have an inequality symbol. And then over here, you're going to have a number. X is greater than 5. X is less than 2. That's all that this one's going to be. So how would you write this one as an inequality? Yep. Yep, that's it. Sometimes people say X is greater than or equal to -4 and less than infinity. Well, I know it's less than infinity. Everything's less than infinity. So you don't have to say that it's less than infinity. Right? You just have to say greater than or equal to -4. So an unbounded interval is actually a little bit less you have to write down. Yep.
If you were to say it's less than infinity, would that go on the right side?
Yeah, you could. What is it? Negative 4 is less than x, which is less than infinity, and that has an equal to. Yeah,
You don't have to, but
you don't, yeah.
it doesn't matter the size on it.
But yeah, if you were gonna put it, I guess that's how you would do it. Yeah. And how about this one? Alva, is that bounded or unbounded?
It's bounded.
Yep, that's bounded. And how would you write that as an inequality?
I would write it negative 8
Yep.
is, I think it's less than or equal to x, and then greater than or equal to negative 2.
Both signs have to point the same way.
No, negative or equal to.
Okay, so negative 3. You want to say that one again for me?
And then less than or equal to.
Yeah. So negative 8 is less than or equal to x, which is less than or equal to negative 3. We need the equal to's because we had brackets. We said this was bounded. Is this open, closed, or half open? Closed, completely closed, which means you can include negative 8 and you can include negative 3. You can equal the two endpoints. All right, now let's try writing it another way. Let's graph it instead of writing it as an interval. So for this, we want to decide what kind of circle we would need, where to put it, and then which way to shape it. All right, what kind of circle, Matt?
It would be closed.
Closed circle on what number? Yep, closed circle on 2. And which way am I going to shade?
Right.
Yep, I'm going to shade. If you set it up, letter, symbol, number. That's how I teach my Algebra 1. Letter, symbol, number. If you put the letter on the left, the inequality tells you which way to shade. If you don't do it that way, then it won't. But it's set up the way it should be, so shade to the right. On Edge Elastic, there's a tool. You'll have like a choice. You'll have something like that, something like that, something like that, and something like that.
Yeah, I think that was on the.
Oh, that was already on the last one?
I think it was.
Okay, never mind then. But basically, it's very simple. You click the one you want. Yeah.
Can we just do a reversal of how you would write that inequality as using the brackets?
So this is an unbounded interval that starts at 2, and it includes 2, and it goes as high as you want to go. So that represents 2 to infinity. So there's 3 different ways of writing the same thing. Inequality, graph, interval. Yeah.
Because a positive infinity is always on the right in that bracket.
Yeah, because when you write an interval, this is always the min, this is always the max. So you could never have a minimum of the highest possible thing in the world. So yeah, it wouldn't make sense that way. How about this one? X is less than 5. What kind of circle do I need this time, Manny?
Open
Where?
on 5.
On 5, and shade to the left. Yep. So, and again, unbounded, unbounded, bounded. Bounded has a start and a stop to it. Okay, so let's make a number line. Ashley, what kind of circle do I need on -1?
Negative 1.
Yep.
Closed circle.
Closed. How about on 3?
Open circle.
And where do we shade?
Through the middle.
Yeah. Bounded is usually shade between. Just like that. So there's 3 different ways that we just went over to represent your answer to an inequality problem. Graph, inequality, interval. Now we're going to look at solving a problem to get an answer that looks like that. So when we're solving inequalities, it's basically the same steps as when you're solving an equation. There's only one extra thing that can happen. If you multiply or divide by a certain number, we have to do something. Does anybody remember with inequalities, if you multiply or divide by a negative, what do you have to do? You have to flip the sign. So if you multiply or divide, not if you add or subtract, just if you multiply or divide by a negative, flip the inequality. Right, so now we'll try solving an inequality and getting an answer. And when we get the answer, they could ask us to write it 3 different ways. Interval, graph, inequality. We'll just do this one as an inequality. Right, so we've got 3 times x minus 1 plus 2 is less than or equal to 5x plus 6. What side of the inequality am I going to start on? What side has some work you need to do? Yeah, go ahead.
The left side.
Yeah, the left side's got a little bit of work we got to do to it. And can you tell me what we have to do?
You have to distribute the 3.
Okay.
X minus 1.
Yep, let's distribute that 3. So we're going to get 3x. And what's 3 times negative 1?
Negative 3.
Negative 3. But how about when you add 2 to it?
That would be negative 1.
Negative 1. So we just did all that in one step. 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. You don't have to do it all in one step. But you can. All right. How about Casey? What would I do next?
Try to get everything you want, like get the 5x and the 3x on the same side and the,
Okay.
and the 6.
Yep. And where do you want it? What do you want to do? Do you want to put the 3x over on the right, or do you want to move the 5x to the left?
Get the 5x.
Okay. How would you move the 5x?
Subtract 5x on both sides.
So that's gone. And if we're going to put the x's on the left, we might as well put the numbers without x's on the right at the same time. So that's gone. And Kelly, what does that give me now on the left side? And how about on the right? 7? Okay. So now we're down to our last step. Why? How am I going to get x by itself and get rid of that negative 2?
Divide negative 2.
Yep. And before I do any arithmetic or even think about that, what should I do right away so I don't forget it? Yep.
Flip the sign.
Flip the sign. Because we just divided by a negative. So this cancels out. And we get x is greater than or equal to negative 7 halves. Remember, it doesn't matter where you put the negative. And that answer could be written as an inequality, which it is, or an interval, or a graph. Yep.
Where did you get the 1 from?
That's when we distributed and then combined like terms with the 2.
Oh.
So we just did both of that in one step. Any questions on that? Okay. So we can solve inequalities on the graphing calculator. There's actually 2 different ways to do it, and I'll show you each way right now. So one way is to use the root feature. Second, calc root. To use that feature, you have to get 0 on one side of the inequality first. So you have to rearrange it so you get 0 on one side, kind of like you're solving a quadratic, and then calculate the root. Once you know the root, the answer is either going to be everything below the root or everything above the root. Depends on the problem. Does it have a greater than or does it have a less than? That's what's going to control which one. So let's try 4x minus 1 is less than 2. What would be the easiest way to get 0 on one side of that in one step? Yeah, Caleb?
Subtract 2.
Just subtract 2. So we're going to get 4x minus 3 is less than 0. Okay, now type in 4x minus 3. And what we're going to be looking for is less than 0 means below the x-axis, means under. So I'm going to be looking for where this line is under the 0, under the x-axis. Okay. So when I graph it, I can see that there is a section of this line that is above the axis and a section of this line that is below the axis. Right here is my 0. If I want to make sure that I stay below the x-axis, would I want to pick x values that are larger than that circle or smaller? Smaller. I want to pick x values to the left because as I go to the left, this graph keeps dropping down. If I go to the right, it's going up and I would be above 0. I don't want to be above. I want to stay below. So we just have to calculate what that number is. And just as a reminder, have we done second calc 0 before?
No. I don't think we have.
You don't have? Okay, so to calculate a 0, it's under second calculate. You press 0, and you have to hit enter 3 times. It's like doing an intersect. First, put your cursor that's somewhere to the left of where it crosses the x-axis and hit enter. That will put a blue dotted line on the screen. Now move your cursor to the right of where you think the 0 is. That'll put another dotted line on the screen. Now the calculator is going to look between those 2 dotted lines, and it's asking for a guess. The guess doesn't really matter. You can move it close if you want to, and then hit enter. And it tells us that this graph crosses the x-axis at 0.75. And we said earlier, we want to pick numbers that are below 0.75. We want to head to the left to stay less than 0. If it said greater than 0, then I would want to pick numbers above them and head to the right. But the answer this time is less than 0.7. Any questions on using method 1 to calculate a root? So method 2, pretty much the same thing, but instead of using root, we're going to use intersect. When you do it as an intersect problem, you don't need to rearrange anything and get it equal to 0. all you have to do is put the left side in y1. Put the right side in y2. And my 4x minus 1 is blue. This one is going to be red. What I'm going to be looking for when I graph this is where the blue graph is under the red graph. That's what I'm looking for now. Where the blue is less than the red. So there's the blue. There's the red. The section in this problem that I want to focus on is right here. And it keeps going. I want to know what values can I fill in for x that will make sure the blue is less than the red. That's in this section. So that's x values that continue heading to the left. Because if you pick x values that go to the right, the blue graph jumps above the red line. We don't want that. So it's to the left. But I need to find that exact point. And I know we did this yesterday when we found a break-even point. So second, calc, intersect, and then just hit enter 3 times. And it says the intersection is at 0.75. This time, we want everything below that because we want to head to the left. Heading to the left keeps the blue line under the red line. So it's the same answer. So whether you choose to do it as a root or you want to do it as an intersect, it doesn't matter. You can do it either way. Just depends on how I feel at the moment, which one I do. And we already solved it, so I'm not going to solve it again. Any questions on method 2? Yes?
The term if you want the axis above or below the intersect value, that would be, is that the greater than or equal to part?
Yep, it has to do with whether you want to be above a certain thing or you want to be below a certain thing. We want it to stay below the red line. So we need to pick x values that go this way. Our x values have to go to the left of that intersection point. If we go to the right of it, then the blue line goes up above the red line. And that's not what we want. All right, so a double inequality. A double inequality is when you have a conjunction. And the goal is to get the x alone in the middle. It's very similar to solving a regular inequality. The only difference is whatever you do to the middle, you have to do to the left and to the right. So if I was going to solve this one, that's how I would do it. I would divide everything by 2. Same rules apply. If you divide by a negative, you're going to end up flipping all your inequality signs. They all flip. Let's try one of these. So I have negative 3 is less than 2x plus 5 divided by 3, which is less than or equal to 5. Okay. Anyone think they see what the first step would be to start getting this x alone? And a hint would be at least to make it so you don't have a fraction in there.
You would multiply everything by 3.
Multiply everything by 3. You multiply by 3, those are going to cancel. And Sam, when I multiply by 3, what do I have on the left?
Negative 9.
Negative 9. And that's positive 3 we just multiplied by, so we're not flipping anything. Max, what would be left in the middle?
2x plus 5.
2x plus 5. And Aiden on the right. What did we have on the right originally?
Oh, 5.
5. And what did we multiply the 5 by? 3. So 15. So now we have 15 on the right. Okay, good. And now we have 2 more steps to get x by itself. What would we do next there? Yep, go ahead. Subtract 5. Here, here, and there. 5's are gone. Negative 9 minus 5 is negative 14. And 15 minus 5 is 10. And my last step. Yep.
Divide everything by 2.
Divide everything by 2. Did we divide by a negative? Did we divide by a negative? No. So we don't flip anything. So the answer is negative 7 is less than x, which is less than or equal to 3. So solving a conjunction, not really that much harder. You just have to make sure whatever you do to the middle, you do to both sides. Questions on that? So yesterday we finished up with solving absolute values that were equations. And today we're going to finish up with the same kind of thing, except we're going to solve an absolute value inequality. It's almost the exact same steps. First thing you want to make sure of is the absolute value is isolated. You got to do that first. And then we're going to split it into 2 problems. So you had something like this. Without me showing you the first one you're going to split it into, does anybody have a guess based on what we did yesterday? The first inequality would be? Man?
Would it be negative? 3x plus 2 is less than 5.
Less than 5, yep. So the first inequality, all you do is take away the bars. That's exactly what we did yesterday. 3x plus 2 is less than 5. Now the second inequality, we did something to this number on the other side. But we also have to think about this symbol today too. So it's almost like we did yesterday, but there's one more step with the symbol. Yeah?
Would it be the exact same except it's a negative 5 and you flip the sign?
Yes. So the second inequality is the same as the original, but you get rid of the bars. And you have to do the 2 things that Matt just said. Flip the sign and make the number on the other side the opposite. So if it was a positive, you make it negative. If it was already negative, you would make it positive. So the first one, take out the bars. Second one, take out the bars, flip, change the sign. Now, when you solve an absolute value inequality, you're going to get two answers. Like we did yesterday with equations. You're going to get something and something. You have to put a word between these two answers. And there's two choices. The answer is either this and this. The other option is this or this. We have to pick one. The way you know which one to pick is you look at the original problem. Look at your inequality. If the original inequality is a less than or a less than or equal to, you use the word and. And the way I remember it is if you have a less than, you use and. L for less than. Less than is an and. Land. So I remember the word land. L means less than is an and. If it's not a less than, well, then it's a greater than. So greater than uses the word or. Gore. I like land. So we'll go with that. So less than is an and. Greater than is an or. Doesn't matter if it has the equal to or it doesn't. Greater than always is an or. Less than is always an and. All right, so we'll do one of these, and that'll be it. I had an and I also had an or. Doesn't matter which one. Let's do the and. Now, kind of already gave it away, but how do I know that this is an and? Yep.
Because it has a less than symbol.
It has a less than symbol. So I'm going to write the word and down right away so I don't forget it. And what would be my first inequality that this splits up into? Well, right. Tell me my first inequality. So remember, same as the original, just get rid of the bars. Perfect. X minus 3 is less than 3. And, now the second one we have to be a little careful. We got to do two things. Three things if you count getting rid of the bars. Yeah?
X minus 3 is greater than negative 3.
There you go. Now we solve it by adding 3 on both sides. So we get x is less than 6 and x is greater than 0. So that effectively means to pick a number between 0 and 6. Not including 0, not including 6. So absolute value inequality, you do have to solve 2 of them, but they're usually very simple. They don't have distributive property or anything like that usually. So this was an and. The one that we skipped was an or, but you can do it the same way. Just break it up and put the word or, but we can go over one like that tomorrow if we need to. Any questions on example 7? All right. So, homework for tonight. Let me just double check the page. Should be page 108 going on to 109. And let's see. Skip 34. And skip 35. Okay, so I think everything else should be okay. Okay, just a reminder, I will be out of school on Thursday. If anybody needs to stay. Progress reports closed last Friday, so anything you make up from this point forward is going to go on your term grade, not your progress report.